All right, guys, today we're going to talk about our exponent rules. The most important two are that you remember the power to a power rule and the same base rule. The power to a power rule is that when I have a to the m to the n, so that means I'm going to have parentheses with a power on the outside. You have no variable in between those two exponents. You're going to multiply the exponents together. So again, when you have a power to a power, you multiply the exponents. When I have the same base, so like I'm multiplying a's and a's, then I'm going to add the exponents together. If you notice the difference here, there is no parentheses in this bottom one, so there's no number on the outside without a variable attached to the exponent. Okay, we are going to look at some examples, so let's look at number 1 first. All right, guys, so here's number 1, and if you notice, there is no power to a power, so there's nothing like a 2 on the outside of this parentheses. There's nothing out here, so none of these numbers, or none of these exponents should be multiplied. The only thing that I saw that you guys really got confused with this is you didn't know what to do with this 12 and this 2. Well, you could really pull this apart and make it 3 separate problems. You could make it 12 times 2, and then you could make it a squared times a, and then you could make b cubed times b to the 4th. And then just simplify as much as you can. Well, what is 12 times 2? 24. What is a squared times a? A to the 3rd. What is b squared times b to the 4th? B to the 7th. And this is our simplified expression. All right, let's take a look at number 2 now. Oh, sorry. For the last one, you guys are probably wanting your keyword for the last problem, and the keyword after number 1 is unicorns. So make sure you write unicorns on your corrections. Okay, so something that you notice about with this problem, right off the bat, the first thing you should see is, oh my goodness, I have a negative exponent. And since you guys kind of struggle with negative exponents right off the bat, what I would recommend you doing is rewriting this expression with that x to the 5th in the denominator. Because it has a negative exponent means you move it. Something you guys really struggle with is you saw this, oh, I have a negative 7, and you thought, oh, I should move it to the denominator. Wrong. Guys, the negative exponent is the only thing that's going to move anything from the numerator to the denominator or the other way around. This is just a negative coefficient. It's just saying I have negative 7 of these. So that should really just stay in the numerator. So now I'm going to bring down the rest of the problem, things I have not touched yet. I haven't touched the y squared, and I haven't touched the x to the 7th. I know this is not simplified because I have 2 values with x's in them. As long as I've got 2 values with x's in them, and I've got no adding or subtracting here, so this is just one monomial, I know I need to simplify the x's. I shouldn't have more than one x in one term. So, in order for me to simplify this, I need to think to myself, where are there more x's? Well, there's more x's in the numerator. How many more x's are in the numerator? There are 2 more in the numerator. So now we've simplified our x's. Everything else has nothing else that can simplify. So our final answer is negative 7y squared times x squared. That is your final answer. A lot of you guys, again, you put that negative 7 in the denominator. So make sure that you're paying attention. Is it a negative exponent or is it just a coefficient? And your keyword for number 2 is rainbow. Let's go do number 3. All right, guys, here's number 3. So the first thing that I see is I've got this exponent on the outside that I know that I need to come back to. That was a big mistake that I saw, was people forgetting to come back to that exponent at the very, very end. So if you need to circle it, put a star by it, make a little note, whatever you need to know to remind yourself, hey, I've got to come back at that end and touch that exponent. The second thing I see is that I have right here a negative exponent, which means that this value, this b to the negative 1st, needs to move. So before I start anything, I'm going to cross it out of my numerator and I'm going to move it down. Now I have 3 separate problems that all can be simplified on their own. So here I've got 24 divided by 8, which is 3. And then I have a to the 5th divided by a to the 3rd. Well, I have to think to myself, where do I have more a's? Well, I have more a's in the numerator. So my final answer is going to have a's in the numerator. How many more a's do I have? When I cancel out, I'm going to cancel out 3 total pairs, because that's how many is in the denominator. I'm going to have 2 remaining in the numerator. Now, for my b's, remember, I moved b to the negative first down. So now they're all in the denominator. I've got b to the 4th and b to the 1st. Same base, and so I add my exponents. This becomes b to the 5th. I have this 2 on the outside, and I have to remember to apply it to everything. Now I have a power to a power. When I have a power to a power, I'm going to multiply my exponents. I'm also going to take that 2 and apply it to this 3, and down here to this b. So now I've got 3 to the 2nd power, a to the 4th power, over b to the, what's 5 times 2? 10th power. And my final answer needs to have this 3 to the 2nd power simplified. So my final answer is 9a to the 4th over b to the 10th. Your keyword for number 3 is stars. So you want to make sure you remember stars. Beautiful. Let's go look at number 4, and then you are done with this video. I'm going to give you some practice problems. All right, for number 4, wow, you guys really struggled on number 4. We've got negative 4, x to the negative 2nd, y to the 4th, times the quantity of 4x to the 3rd, y to the 2nd. I don't know how, but somehow some of you guys ended up with a polynomial with multiple terms with addition and subtraction in your final answer. Nowhere in this problem is there addition or subtraction, so it's only multiplication. So I don't know how you guys ended up in the end with addition and subtraction. What I do notice is that I have a power on the outside of a parentheses. So I should really apply that first, as long as everything inside the parentheses is as simple as it can be. I'm looking inside the parentheses, and I don't see anything in there that I could simplify any further. So I'm ready to just take that 2nd power and multiply it to everything. So now, inside these parentheses, I have 4 to the 2nd power. I have x to the power to a power, so I multiply. 3 times 2 is 6. And then I have y to the 2nd. Well, I can still simplify that further because 4 to the 2nd power is 16. So I have 16x to the 6th, y to the 2nd. Now I'm going to look at my other monomial, which has nothing inside that can be simplified except for this. I notice that I have an x in the numerator that has a negative exponent. So my next monomial is going to be negative 4 y to the 4th, and then that x is going to move to the bottom. So now I'm going to multiply everything that I've got in the numerator. So that's all of this here. So I've got negative 4 times 16, which is negative 64. And then I'm done with my coefficients. I've got x to the 6th, and I have nothing else in my numerator to multiply with, so I've got x to the 6th. Then I have y to the 4th, and I have y to the 2nd. Same base, so I'm going to add my exponents, and I have y to the 6th. But I can't forget that here in my denominator, I have x to the 2nd. Am I as simplified as I can make this problem? I'm not, because I cannot have multiple x's in the same problem when it's simplified. So I need to somehow get those x's simplified. So, sorry. I need to cancel these out. I notice I have more x's in the numerator, so in my final answer, I'm going to have x's in the numerator. 6 minus 2 is 4, so I know I'm going to have 4 left once I cancel out the 2 in the denominator. And I'm left with y to the 6. So this is my final answer. This one really wasn't as tricky, but you guys really had a hard time with it. I think you were trying to FOIL somehow. We only FOIL when we have binomials or trinomials. These were just all multiplication monomials being multiplied together. Your keyword for number 4 is hearts, and then I am going to give you some practice problems. Here are your 2 practice problems for this section. So I've got 45x squared y over 5xy to the 4th. And all of this is to the 2nd power. So why don't you take a moment and solve that problem. Alright, so if you took some time, hopefully you paused and worked out that problem. You did 45 divided by 5, which was 9. You did x squared over x, and you knew that you had more x's in the numerator, so you had 1 left. And then you notice that you have y's in the denominator, and when you subtract or you cancel out the 1 in the numerator, you're going to have 3 left. And then you remembered to take all of this to the 2nd power. So I have 9 to the 2nd power, which is 81. I have x to the 2nd power, which is x to the 2nd. And I have y to the 3rd to the 2nd, which is a power to a power. So I get y to the 6th. So hopefully you guys were able to do that. Okay, we're going to do one more practice problem. And it is 4x to the 3rd, y to the 4th, times, to the 3rd, times 2xy to the 3rd to the -2nd. So pause right there, and I want you to solve this problem. Okay, hopefully you guys paused and solved the problem. If not, do so now. The first thing you should see is that I have a negative exponent on the outside of all of this. So that means everything here is going to move to the denominator. So now I'm going to have 2xy to the 3rd to the +2nd. So I no longer have this part here in the numerator. Now I have to apply my powers to a power. And remember, power to a power applies to everything, and it means multiplying. So I've got 4 to the 3rd. I've got x to the 9th. And I have y to the 12th. All over here, I've got 2 to the 2nd. X to the 2nd. And then y to the 6th. So now I can work step by step on simplifying. 4 to the 3rd is 64. X to the 9th, I'm just going to go 2 to the 2nd is 4. So what is 64 divided by 4? It's 16. And then I've got x to the 9th over x to the 2nd. Well, when I've got x to the 9th over x to the 2nd, I know that I have more in the numerator, and when I cancel out 2, I'm going to have 7 left. And then for my y's, it's the same thing. I've got more in the numerator, and when I cancel out the 6 that are in the denominator, I'm going to be left with 6. So this is my final answer, 16, x to the 7th, y to the 6th. Alright guys, hopefully you feel like you could conquer problems like 1 through 4, and you learned a little bit through these practice problems. You can look for more videos in the next day or two over the last couple problems.